Panel discussion on geospatial technologies for mitigating water-related risks. The moderator for the session is Mr. Nikhil Kumar. He's the head strategic alliances for Southeast Asia and India from Here Technologies. In the panelists, we have Mr. Iftikar Ahmad Hakim, Director Planning and Coordination, Jhelum Tawi Flood Recovery Project, Mr. Nagarajan Rajendiren, Head GIS and Remote Sensing, MS Swaminathan Research Foundation, Mr. Anil Beas, ADE Bhakra Beas Management Board from Chandigarh. And we are also waiting in some time for Mr. MS Jhelum, Chairman Ganga Flood Control Commission. He's just joining us in some time. So in the meanwhile, I hand over the session to Nikhil.
Good afternoon, everybody. So, so good afternoon. And so Mr. Ahmad, Mr. Rajendiren, Mr. Beas, welcome on this panel. And the idea is, so far we have been hearing about how to optimize and maximize the natural resources water in its management and best use. Now we have a different conversation in this panel, which is how to fortify ourselves against some of the risks that water can bring in. And as we all know, because of the very diverse climatic nature and rainfall distribution across the country, we have both drought and flood happening at the same time. And because of huge and burgeoning development activities taking place across the country, and as well the burgeoning population, it puts a stress on climate, and then it results in one single cause of natural disaster, which is flood, taking life, livelihood, population, a lot of stuff. Now, you all are experienced enough in managing disaster, especially coming from the water, right from its assessment to mitigation to preparedness to recovery and creating a response out of it. And based on my experience, I'm not an expert on natural resources or water resources, but for last 25 years, I've spent enough time in seeing the use of technology into different walks of life. And I personally believe that GIS and geospatial technology as a whole has a lot to play in this whole continuum of assessment, preparedness, recovery, response. Right from the 4 parts of geospatial: data collection, data management, planning, analysis, and then sharing with different stakeholders in creating a response and recovery. So I would like to start with Mr. Ahmad, that what are the initiatives by your project under which you bring in geospatial to the core of managing and mitigating risk coming out of?
Good afternoon. I'm Iftikar. I'm basically a professional town planner, has been working here for the last 30 years, mostly as a town planner. For the last 4 years, I've been working in the World Bank funded project, which is called Jhelum Tawi Flood Recovery Project. It's actually the project which was sanctioned by the World Bank after the 2014 floods of Srinagar, and the floods also happened in other parts of valley. So I started actually using GIS from 2003 when I was doing my graduation in planning, but I was doing a project on I was trying to understand the issues related to human development in a city which is called Louisiana, which is called New Orleans Parish. Parish means a city in the Louisiana. This is the capital city of Louisiana. So I was using both statistical as well as GIS tools to understand why are certain areas worse off than the other areas. And I found that this GIS provides an excellent tool rather than because GIS provides you analysis which is geographical oriented, which is connected to the geography, while the statistics provide you a general analysis of the issues and problems. We did 2 major master plans for Valley. One was for Pahalgam. Pahalgam is a well-known destination. And then we did Srinagar master plan post 2014 floods. So we used actually, how can we use, what we try to do is to use all the tools of GIS, do a layered analysis for understanding the floods and other disasters. So it proved to be an effective exercise because GIS layered analysis became actually the platform on which we did the land use planning of the city of Srinagar. Post that, I joined the World Bank team working in the state on the implementation of the Jhelum Tawi flood recovery project. It's around 250 million USD project. While in around most of it is on the recovery, but a huge amount of money is also being spent on the multi-hazard risk assessment, river morphology studies. We are doing the multi-hazard assessment of the whole union territory of J&K and Ladakh, which actually includes all major 9 disasters. That is one part of the state. Then we are doing 2 major studies on the river morphology. One is Jhelum and another is Tawi. So actually, we are doing huge. There's a lot of analysis, and the work is going on 3 major projects. Most of the work is related to GIS. Multi-hazard risk assessment is completely on GIS platform, while the other morphology studies use other tools like HackRAS, GeoHackRAS, etc. So I think when I was doing planning, we were not fully prepared kind of disasters we face. GIS actually provided a tool of understanding, a layered understanding of the disasters which the cities or the regions can be stuck. That's it. That's what we have been doing for the last 4 years.
Thank you, Mr. Ahmad. So my next question will be to Mr. Beas. So when it comes to dam, and GIS has geospatial as a technology as a whole, a lot to offer in terms of how dam can be monitored, because that itself becomes one vulnerable point of collapse for enhanced risk. And I have understood that a lot of technologies, whether it is accelerometer or it is optical sensors or co-located GNSS along with meteorological sensors, which helps in assessing the risk involved at a particular time, even to the extent of real time in managing and monitoring dams. So your experience in terms of use of technology in the dam.
Thank you, sir, and good afternoon to everybody. As your voice was disturbed and I have some part, may I have missing your question. So first of all, what we are doing and how we are mitigating the floods and everything. First of all, we are working in this Indus Treaty Organization catchment area like Satluj and Beas, where we are having transboundary condition. 2/3 of our catchment lies in China. So even if we are trying to put the telemetry or anything, we cannot put, or even we cannot get the real-time information. And our elevation ranges from 500 meter to 7,400, where we cannot put the rainfall index is there, temperature lapse rate is there. So before this project or before National Hydrology Project, we is doing the manual work, and we are not having any information regarding the transboundary condition. But in today, what we are doing, our laptop can automatically download the data, update the data, run the simulation, and give me the information. So regarding your question, even we are getting the real-time data. Before that, in some of the portion, the water may come into the reservoirs. So latency period is hurt us. But if I am talking in another way, that what information I can get, so it's still I am sitting here. I know what will be the condition on 24th to 27th of Feb, and that information is 80% accurate for me. 20% I can cover with some computations and the modeling purpose. So this all, if I will take the particular example of the Satluj Basin or the Punjab floods, then that is in the recent time, on the 17th to 19th August. So at the morning or 3 days and 4 days before, we are knowing that our catchment will be flooded or our reservoir can get this tune of water. So we are having 3 reservoirs. In one reservoir, we are knowing that we will get 50,000, out of which 8,500 we can divert, and remaining water will come into our second downstream reservoir, and this reservoir level may go up to 7 to 11 feet. In the case of Bhakra, that was a more critical stage, and we get the quantitative precipitation and forecast, and we are watching every hour real-time data, whatever we are getting from the international sources like GPM, TRMM, and every sources, and we are watching and we are releasing information to our management what will be the next our reservoir level and what will be the range of that reservoir level. So we are knowing, we are sitting in the Chandigarh, a similar kind of that from Manali to the Pong reservoir, and similarly we are knowing the downstream conditions. So almost 90% of the flood we have absorbed in the Bhakra reservoir. Only the contribution which is from the downstream area, and that is only due to the small spatial or temporal displacement of the forecast. That was the main reason. Otherwise, the system nowadays is reliable, and we are working on it, and we rely on it, and we are taking the decisions on the basis of spatial data and the models which we are running at present. But our journey was very tough from 2008, 2013, and then cloud burst, Kedarnath tragedy was also there. So all these are happened. Nowadays, we are having a good, so my laptop in the morning for 1 hour do my duty for next 10 to 15 days and give me the information, correct information, rainfall events, temperature events, and all this.
Fantastic. I mean, you have summed it up so well as to how you're using technology with the reference station, giving you the GNSS positioning as well as the total electron count and precipitation for you to be able to forecast as to what the next hour reservoir level would be. That's great. I mean, this is really very fascinating. So I was just saying, commending the work that you guys are doing, and especially in assessing the reservoir level using the latest geospatial technology, including meteorological sensor, TEC, precipitation, and co-located GNSS, to be able to accurately say as to what the real-time reservoir level would be. That's a great, I will say, compliment to the GIS technology for coming to an aid for such a critical stuff. Now, turning gears, coming to Mr. Rajendiren. Now, I heard Mr. Ahmad also saying about different technology in actually use of in planning and assessment. As well, I also heard Mr. Beas talking about telemetry. Now, the question comes in, how GIS integrates different type of techniques and tools with GNSS geospatial. And when we say geospatial and remote sensing is huge, right? From the Earth observatory data to the rain fade data, the meteorological sensor data, the GNSS data, a lot of different thematic maps, all put together. How do you make use of geospatial playing a integrating conduit to this available information reservoir for mitigation of flood and also the warning for drought, whatever the case be? We are not able to hear you. You may have to switch on your audio. Yeah.
Yeah. Sure. Yeah. Good afternoon, everyone. Thanks for giving this opportunities. Coming back to the discussion, see, for flood monitoring and drought things, see, we are working exclusively in some of the highly drought area in our Tamil Nadu region, where we use extensive thematic maps and SAR data and other things to assess the soil conditions and other things actually. So this kind of remote sensing can be used for this kind of analysis part. And coming to the flood management, we have to study that what is the capacity of the water bodies and how much it will flood. So much of I feel like still so much of study has to be taken in this aspect actually. So even if right now I'm from Chennai and talking, so very well, often we are getting flood. Even Chennai, the terrain is very steep, very small region terrain. It ranges from 5 meter to 1 meter terrain actually. So where the government has ALTM survey-based data, but unfortunately the data is not used for the mitigation part. So every time when there is a rain, you all know that Chennai city will get flood actually. So how this can be mitigated? Whatever the data we have, that has to be effectively put into the planning part, and it has to reach the disaster management committee. I feel there is a disconnect in that thing. Even the scientists, whatever we're doing in the research in the laboratory, it is not properly going to the implementation agencies. So that things has to be strengthened. So we have enough geospatial data with us in our hand, but unfortunately, we are not using that during our disaster period. Even I'll take the case of Chennai city itself actually. So we all know where the water can be stagnant. We already there's a map saying that these are some of the hot spots in the region, and there is so much of automatic weather stations also placed in the city, and the water level is also measured every time. But when coming to the flood kind of situations, it's always challenges for the mitigation. Even for moving the people away from that place, also it's become a challenge. As I said again, the data whatever we are having should be put into public use, and that has to be studied properly, where we should have the very high resolution data. And thanks to our recent geospatial policy also, hopefully it will give more opportunity to work in the high resolution satellite images, high resolution survey things, where we can get real-time data, people can measure all this data and everything. And to some extent, the weather, recent technologies advancement in terms of radar and all, people are getting the real-time weather advisories. That is really good actually, but I would say that kind of information has to be taken by the government of India also. And as far as Chennai is concerned, more and weather bloggers are giving very accurate data than the government institutions. So that modeling also be taken very serious, and that they have to do it very effectively for this kind of flood modeling and other part actually. And coming to the drought, right now we are working in collaboration with the JZ, where we are working in the Ramnavaram district, which is a drought-prone area in our state. It's a down south near Rameshwaram, where we put our GIS and remote sensing effectively for planning the Gram Panchayat level. This project is especially for the Ministry of Rural Development, and this is part of the MGNREGA project, where we use the remote sensing and GIS part as well as non-spatial data, and there is something called composite water resource management plan. So we planned a composite water resource management plan which has a spatial as well as non-spatial concepts, and that has to be placed in that district. Where we are, there's almost 460 Gram Panchayat are in districts, where the detailed planning has been taken for each Gram Panchayat, and it is consolidated to the entire district in 1 year. So this will support the MGNREGA activities. So as far as we know, so much of MGNREGA activities happening in the country. So people are thinking only few works are MGNREGA, where the desilting.
That when we talk about challenges of use of technology, there are 3 levels.
Yes.
One is the policy level. And, for last 20 years, I've been talking about the policy becoming one single challenge. Today, we can definitely say that's not a concern. Because, and I'll come back to you when you talked about, while we have different facets of data, different sets of data, when it comes to mitigation and the entire stakeholding should be having access to data is sometimes a difficult proposition. And I'll come back to that because that's driven by policy, which is today definitely lifted off. That could be an administrative region to kind of make it still a silo and keep it kind of fortified to what I created. And the third reason could be a technology region, which facilitates on one single platform that you are able to, as a marketplace, share different kind of data, and as a workspace, use that data for different application. We can choose, but you should have at one single place where that makes sense. So these are the 3 levels. So just as a round robin, your experience, Mr. Beas, and you can bring in the 4th if you feel that is also a challenge. So administrative, policy, technology. What is the challenge that you face in kind of implementing GIS or geospatial technology in whatever you are doing in terms of management of the flood? As well, the second question would be, what you expect from the industry, the Association of GIS Industries, to help you with?
Yes, sir. First of all, I am honest, then we never get the Indian satellite data. We have to start right from the searching site, from the NASA site. And even on the websites in gray market, some kind of things, we will get the data which are in the classified category. I am also from the classified category. So first of all, the Indus Treaty, we cannot disclose our data even. So first thing is that whenever we are having observed data, then when we can simulate the system and we can. So regarding the policy, next one is this open source map and restricted map. Survey of India, we cannot get the contour elevations of the nearby area because my area starts from the China border and ends at the Pakistan border. So almost the flooding region comes into the Pakistan region and inflow region comes from the China side. So even other thing is that who will give me the depth of the river, who will give the height of Everest, and who will give the depth of Ganges. That is the Survey of India or one kind of organization, because my spatial data or digital elevation data will be at, so there is a lack of hydrographic data even available. We are having eco sounders, ADCPs, and we can monitor all this information and put into the, regarding technology, I must say that we are having the parts in the technology right from 2008 when we start that 1 degree resolution is there. Almost there is a red cross symbol was there for India because we were not cooperating or we are not having the data. So then we were start getting 1 day rainfall. Then there, now today I am getting 10 kilometer by 10 kilometer grid. I am getting 4 kilometer by 4 kilometer grid for forecast and from the Indian agencies. So today I am saying that my data are available on the open source. Softwares are available on the open source. But if I am looking and comparing with US and Europe, then there are two things are there. They are making a global website and there are national websites. And if I compare those resolutions, then there is a day-night difference between those resolutions. If I am talking and I am getting the data from GLDAS and NLDAS, NLDAS is giving for the US region, 32 parameters are there and they are resolution of 1 kilometer. But for Indian region, I am getting the 25 kilometer. Even we are very much need of snow water equivalent grids, and they will give me for 1 month before. And for US region, today real-time SWE grid was available there. When we are putting our full labor, and then we are not getting hydrologically correct digital elevation model. We have to give going for LIDAR, and even we are not having this much accurate land data even. So these are some of the problems, but even then we can get the practical results. We can get the, so those are almost things that I am having 70,000 square kilometer area, lead time is too much. My reservoir operations are having, as per Indian conditions, we are having too much safe conditions to play with. And we are having some foundations or we are having some rule and regulation, old thumb rules, they will guide us. So we have to work in between two lines. And although we are having problem and we are having the same thing. This is
thank you. Thank you, Mr. Beas. I mean, very comprehensive. I get your point, and we will try to kind of rephrase that once we try to do the conclusion. Mr. Ahmad, so your thoughts on those challenges?
I think there's a lot of gap between actual technology and its understanding at the governmental structures. Another thing is this, which Mr. Beas raised, is we have GIS technologies available, but take the case of Jhelum. For the last 2.5 years, we have been trying hard to get a DTM. First, we tried through a private vendor, then through Survey of India. We have wasted almost 2 years. We would have completed this study in 2019, but because of the lack of DTM, we don't get the DTM with vertical accuracy, which is better than 0.5 meter. And we have been striving hard. We have been getting the Survey of India. And there are so many issues. So that is another aspect. One, we have to raise the level of the governmental structures. Actually, their capacity building has to be done. How can they use the technology for policy framework? That's not there. Then we cannot use technology unless we have the other tools like the DTM, DEM available, which is prerequisite for actual policy analysis. These are the issues which we are facing for the last 2.5 years.
Okay, thank you. Mr. Rajendiren, what's your take on that?
Yeah, I completely agree with both the participants. And my view is like the same actually. So we have to create a capacity building exercise to all the government agencies who are implementing, because I feel like there's lack of geospatial knowledge with them actually. Because they are the users, they should have the geospatial knowledge better than private sectors. So always we feel difficult in that way actually. We have to convince them and we have to explain them what is this, what is how it's going to use it for them, something like that. And even the data, whatever they're having, they don't know the value of that data actually. So that has to be properly used. And finally, I would say that we need a capacity building for the entire in government implementation agencies actually. That would be more important. Thank you.
Thank you. So this was a very wonderful conversation. I wish we had more time to go on a little more in detailing. But in conclusion, what I would like to say is that I mean, the use of technology is definitely well felt. Not only that, we are now talking about how GIS and geospatial can be used, or projects can benefit when it talks about assessment and mitigation. But it's being used as we speak. Whether it is as Mr. Vyas talked about, real-time understanding of the level of reservoir by collecting real-time precipitation level, pressure level, total electronic count level, and then co-locate it with the GNSS sensors, and precisely saying what the next hour reservoir level would be. Or Mr. Ahmad about multi-hazard assessment, what he did for Jammu and Kashmir, and also used different technology alongside geospatial for river morphology study. As well, in the case of Mr. Rajendiren, kind of making use of GIS remote sensing for plot planning. So it's very comprehensive conversation as to how we are making use of technology in different spheres when we talk about water risk management and assessment. Some of the concerns that was expressed was that starting from Mr. Vyas, when he talked about lack of hydrologically correct maps. And as well, kind of sounded on the similar lines by Mr. Ahmad saying that I want a 5.5 meter contour data, I'm not getting it. I want a DEM or DTM, I'm not getting it. And before this conversation, Mr. Rajendra also talked about that we have a lot of data, but making that into one single platform so that can be used at the time of mitigation of disaster, with the people at the stakeholder team, maybe on the same time, at the same platform, 5 different people, enforcement agency, planning agency, disaster management agency, all are kind of putting their mind on top of it, and on a real time doing that. That's not there, despite the availability of different sets of data, which could be made use of. So in conclusion, I personally believe those 2 concerns about the availability of data, now that the whole data policy have been democratized, deregulated. Earlier, it was only within the domain of the government and few agencies to actually create that data. And therefore, there was this silo mechanism in which they were saying, no, it's quite close to my heart. Nobody else has it. Now that it has been opened up, you will see far more business reason for people to collect and disseminate that kind of data, making way for easy availability of the data. Once you start making a business sense out of it, definitely the real democratization starts happening. As well, the all actual data which is created by government fund has to be distributed free of cost or with a very modicum of cost to private companies and free of cost to the government projects. That will definitely bring a lot more simplification, and people will work on how to facilitate that free data through the concept that I shared as a platform, marketplace and workspace. With that, I believe we should conclude saying that with this policy, availability of data will definitely go high. And as the technology is growing importance and significance in mitigating and assessment of water-related risk, more that you will see in coming days and years, the use of technology coming through. So thank you, Mr. Rajendran, Mr. Ahmad, Mr. Beas, for a wonderful conversation. And I feel that as an association, we'll be able to help you further once data as a whole is available. Shared with all country. Thank
you. Thank you very much.
Thank you, Nikhil, for the moderation. I would like to extend my sincere thanks to all the distinguished panelists for sharing their insight on how geospatial technologies can be used for mitigating water-related risk. Thank you, everyone.